Hey guys, welcome to my channel. I don't know how you got here, but I do hope you'll stick around. In this particular video, we're going to be talking about the anatomy of arches, more specifically masonry arches. So I've drawn here a very crude Roman arch. The arch is basically an opening, a door, a pathway, a window, a portal, if you would, that consists of curved or semicircular components. So an arch actually springs off from the impost. The impost is this feature right here. Right there. Okay, we have two imposts. All right, connect those, and we're going to call that our impost. Okay. Okay. The springing point is right as the arch comes off of the impost. So right here in this area, we have the spring of the arch. Okay, and that of course means that on the opposite end, we also have a spring. That first particular stone that comes off the impost, where it springs off the impost, we call that stone. So we have two again. We call that the springer. Okay. The wedged-in stones that create the arch are typically called, I don't know if I'm pronouncing this correctly, but I believe it's pronounced voussoirs. Okay. So those are the main components of the arch so far, but the most important part of the arch is this piece right here. This component is called the keystone. Okay, and it's usually the last piece that is installed in the arch. So the keystone is meant to force, cause pressure, in other words, distribute between all the voussoirs. That way it stays in place. Okay, and then it leads downwards and it carries the weight above the arch. Yeah, we construct an arch with a framework known as centering, right? Okay. So as I said, centering is a framework that would support the arch as you're putting it together. So usually that would be made of wood, but you can also use different materials that are rigid and strong enough to support all the pieces. Starting from where the arch would spring off, which would be along this line right here, going to the point, the bottom of the keystone, we would call that the rise. Okay, so this height right here, this is what we call the rise. Okay, the inner portion of the arch is known as the entrados. Okay, so the inner part of the arch, the inner perimeter, let's say, is called the entrados. And the outer perimeter, of course, of the arch is what we call the extrados. Oops, extrados, there we are. So some masonry arches will consist of moldings along the voussoir. So if we were to cut a section here, right here, if we were to get this part, and we'll make like a section line here. Oops, yeah. Section right there, right? And we take that out. And we look at the voussoir. It will consist of a molding, right? So let's go ahead and fill that in right there. So what we have here is like a molding, right? So that molding on the voussoir is what we call archivolt. Okay? Archivolt. Hope you guys can still see that. But yeah, just an additional note, the archivolt is not always that simple. It can be much more ornamental and much more grander in scale. So now we're talking about like design elements of the arch. Another design element of the arch is what we call the spandrel. ornamentation that goes between the arches in this triangular formation, usually up here somewhere, right? So these, all of those are what we call, okay, spandrels. We'll just keep it in singular form. Okay, so we have the rise as the distance from the impost to the highest point of the opening of the arch. We call that the rise, but the actual highest point of the arch is what we call the crown, okay? Right? The pressure going downward, yeah, on both sides, on either side of the arch, that is what we usually call the haunch. Just to correct myself, what I meant to say is that the haunch is the feature of the arch that carries the pressure from either side. Okay? Okay. There are also other types of arches that you wouldn't think were actually arches. Flat arch, so as the name suggests, would consist of an arch, would consist of a flat arch. What makes this different from the post and lintel setup is the keystone, okay? In a flat arch, you would still have a keystone. The keystone is what's continuing the pressure of all the pieces wedged in to the arch. A typical flat arch would consist of the voussoirs all meeting up into all aligning to the center of a certain point, right? We also have what's called a French flat arch, right? And what happens in the French flat arch is, instead of all of them meeting at some central point, they are all the voussoirs are now parallel to the keystone. Yeah, so this representation now would look like this. Sorry. They would all just be parallel to the keystone. They no longer, the alignment of each voussoir no longer meets up at a certain point. Another type of arch that we have is what we call the triangular arch, okay? The triangular arch differs from the typical arch setup because it no longer has a keystone. Instead, it has two pieces that wedge up against each other, or rather lean against each other. So the force is pushing in that way, and that area carries the weight above it, okay? And typically, these are found in somewhat primitive setups, right? That would be our triangular arch, okay? So we have the flat arch, and the triangular arch. Okay. The last type of arch we have is what's called the corbel arch, right? If you have your setup, right, you have your two sides. Right? And you have your flat here. What you do is you take a bunch of stones and you simply stack them in such a way that they all will meet up at the center. Okay? There. Just an additional note that the corbel arch is actually sometimes referred to as a false arch, and that the top stone is known as a capstone. I'm not going to talk about the different kind of arches right now, but because this is just purely about the anatomy of the arches. I just want to point out that not all arches consist of curves. Just so you have a little history lesson. Okay, so I'm going to go ahead and draw that right here. Okay. You have two posts, and you'd have one beam atop. Okay. The problem was, the longer that the lintel got, the more structurally unsound it would be at the center. Okay, so during the Roman times, especially, they were trying to figure out how to they were starting to figure out how to work in plumbing into their system, into their lifestyle, right? And they had to figure out how to traverse water in such a way that it wouldn't require having to travel to bodies of water and bring it home. The way they found it was through the use of gravity, and they would just go to a high point and have the water come to them. But now, if they just did a complete post and lintel system, the longer the span of the lintel, the higher the chance of it having structural failure. Okay, and they didn't have enough stones to fill up this wall or this opening. That would take them forever. So what they did was they did a bit of math, and then they discovered that they could build longer spans through the use of arches. Because what happens now is all they have to do is make two very strong posts. Okay? And so they would wedge their voussoirs, building up on both sides. Okay? And they would have their centering to hold it up as they're building it. And as they fixed it, they wedged their keystone where all the pressure, all the weight was being carried. Now, the weight is carried over and carried by the haunch onto the post. So that's the impost where it's connected, right? So it springs up, you got the keystone. The pressure of the weight above it would go into the two posts. So they just had to make sure that the posts were strong enough to carry the load on top of it. We do see arches pop up in designs for aesthetic reasons, yeah. But the actual scientific reason that people would use an arch is to negate the problems that you would have for a span that would be too much for a typical beam. So this is the typical anatomy of an arch, and with a little short history. I know it's a bit all over the place, but I do hope you enjoyed this video, and yeah, take care everybody. Bye-bye.